In this video, we're going to look at an example of partial fraction decomposition where the degree of the numerator is greater than the degree of the denominator. So we have to apply long division first. Let's go over some theory first. Given a rational function, f of x is equal to p of x divided by q of x, where the degree of the numerator, p of x, is equal or greater than the degree of the denominator, q of x, the first step is to apply long division first, so that the degree of the numerator becomes less than the degree of the denominator. Afterwards, we apply partial fraction decomposition in the usual way. Let's look at an example. Here we have f of x is equal to x cubed divided by x squared minus 1. What is the highest power in the numerator? Well, the numerator is x cubed, so the degree of the numerator is 3. The denominator is x squared minus 1. That's a polynomial of degree 2. So clearly, the numerator has a higher degree than the denominator. 3 is bigger than 2. We apply long division first. So let's look at an example. Here we have integral x cubed plus 3x squared plus 4 divided by x squared minus 1. The numerator has degree 3. The denominator has degree 2. 3 is bigger than 2, so we apply long division first. Let's do the long division process. So we have x cubed plus 3x squared plus 0x plus 4 divided by x squared minus 1. X squared goes into x cubed, x times. Now distribute. X times x squared is x cubed. X times minus 1 is minus x. Let's put a filler here, 0x squared, and plus 0, another filler, and now subtract. X cubed minus x cubed is 0. 3x squared minus 0x squared is 3x squared. 0x minus x is plus x. 4 minus 0 is 4. Now 3x squared goes into x squared. How many times? That's 3 times. We get 3 times x squared. That's 3x squared. 3 times minus 1. That's minus 3. And we'll put a filler here, 0x. Subtract. Make sure to put a bracket here. 3x squared minus 3x squared, that's 0. X minus 0x, that's x. 4 minus 3 is 1. Sorry, 4 minus 3 is 7. Double negative is a positive. So we get x plus 7. So let's rewrite x cubed plus 3x squared plus 4 divided by x squared minus 1. This is equal to x plus 3, the quotient, plus the remainder, which is x plus 7, divided by the denominator, x squared minus 1. This part here, x plus 3, is going to be easy to integrate. Easy to integrate. It's just a polynomial. And this part here, x plus 7 divided by x squared minus 1, we're going to apply the partial fraction decomposition. All right, so what we have is integral x squared plus 3x squared plus 4 divided by x squared minus 1, integrated with respect to x. We applied long division to obtain x plus 3 plus x plus 7 divided by x squared minus 1, integrated with respect to x. Let's split up the integrals. So we have integral x plus 3 dx plus integral x plus 7 divided by x squared minus 1 dx. Now let's integrate the easy part. Integral of x is going to be x squared over 2, reversing the power rule. Integral of 3 will be 3x plus the integral of x plus 7 divided by x squared minus 1. So now we can see that the integrand is g of x is equal to x plus 7 divided by x squared minus 1. The degree of the numerator is 1 because x plus 7 is a polynomial of degree 1. The degree of denominator is 2 because x squared minus 1 is a polynomial of degree 2. 1 is less than 2. Let's apply partial fraction decomposition. So we have x plus 7 divided by x squared minus 1. This is equal to x plus 7 divided by x minus 1 times x plus 1. Applying partial fraction decomposition, we get a over x minus 1 plus b divided by x plus 1. This is the case of linear factors in the denominator. So now let's multiply both sides by x minus 1 times x plus 1 so we can clear out the fractions. We will get x plus 7 is equal to a times x plus 1 plus b times x minus 1. Let's multiply this all out. We get ax plus a plus bx minus b. Alright, so what we have is x plus 7 is equal to ax plus a plus bx minus b. Let's rearrange this. We get x plus 7 is equal to ax plus bx, putting the x terms together and putting the constant terms together, a minus b. Now let's factor out x. We get a plus b times x plus a minus b So now let's equate the coefficients of x. We have x to the 1. So on the left-hand side, the coefficient of x is 1. On the right-hand side, the coefficient of x is a plus b. Now let's look at the constant term, x to the 0. On the left-hand side, the constant coefficient is 7. On the right-hand side, the constant coefficient is a minus b. Now we have a system of equations, two unknowns, and we can solve this. So let's look at the first equation. Let's plug a is equal to 1 minus b into the second equation, into 7 is equal to a minus b. And we will get 7 is equal to a, which is 1 minus b, and we will get 7 is equal to 1 minus 2b. Subtract 1 from both sides, and we get 6 is equal to minus 2b. Divide both sides by minus 2, and we will get b is equal to negative 3. Now let's plug b is equal to minus 3 into the second equation, into 7 is equal to a minus b. And we will get 7 is equal to a minus 3. So we get 7 is a plus 3. Solving for a, we get a is equal to 7 minus 3 is 4. So now we have done the partial fraction decomposition. X plus 7 divided by x squared minus 1. We factorize the denominator. So we get x plus 7 divided by x minus 1 times x plus 1. Then we apply the partial fraction decomposition. We have a over x minus 1 plus b over x plus 1. And we found a and b. So we have a is equal to, a is 4 over x minus 1. And b is equal to negative 3 divided by x plus 1. So the partial fraction decomposition has been completed. Alright, so let's review. We have integral x cubed plus 3x squared plus 4 divided by x squared minus 1 dx. We did long division to obtain integral of x plus 3 plus x plus 7 divided by x squared minus 1 dx. The first part, we can readily integrate that because that's just an easy polynomial. So integral of x plus 3 is x squared over 2 plus 3x. The second part is basically a partial fraction decomposition. So we factorize the denominator and we apply partial fractions and we obtain the coefficient a and b. So all that remains is to solve the second integral. So let's carry forward the solved integrals from before. That's x squared over 2 plus 3x. Let's split up the integrals. We have integral 4 divided by x minus 1 dx plus integral minus 3 divided by x plus 1 dx. Let's remove the constants outside the integral. So we have x squared over 2 plus 3x plus 4 integral 1 over x minus 1 dx minus 3 integral 1 over x plus 1 dx. Constant passed right through the integral. Now we can integrate term by term. So we have x squared over 2 plus 3x plus 4 times, what is antiderivative of 1 over x minus 1? This can be done by U substitution, and we will show that later. So that's going to be log of absolute value of x minus 1. Minus 3, what is antiderivative of 1 over x plus 1? That's going to be log of absolute value of x plus 1 plus c. So the result will be x squared over 2 plus 3x plus 4 times log of absolute value of x minus 1 minus 3 log of x plus 1 plus c. Now let's review some of the integration that we did. So most of the time we integrate something of the form 1 over ax plus b dx when we do partial fraction decomposition. The result is just log of absolute value of ax plus b divided by a plus c. This is done through U substitution. We're letting u be the denominator. U is equal to ax plus b. Differentiate both sides. Du is equal to a dx. Divide by a, and we get dx is equal to du divided by a. The reason we have a here is exactly the same reason that we divide by a here, because of the U substitution. Let's look at another case that we did. So integral 1 over x minus 1, this is just log of absolute value of x minus 1 plus c. And this is another case of U substitution. We let the denominator be u is equal to x minus 1, differentiate both sides, du is equal to dx. And the last case, integral 1 over x plus 1 dx, that's going to be ln of x plus 1 in absolute value plus c. We let u be equal to the denominator, u is x plus 1, differentiate both sides, du is equal to, and derivative of x is 1 dx. There it is. All right, thanks.